Good morning once again. Today this video is going to be my third video on the chapter relation and functions. In the last video, that means in the video number 2, already we have learned about relation types. Also we have learned all the types of the relations elaborately. Now today in this video we shall be doing some problems on the basis of that. Otherwise nothing will be understood. If you only study the theory, nothing will be understood. So you need to apply it through the problems. But before that we need to recap the relation types once again. Now let us recap. If you can remember, the relation had 3 types, right? Reflexive, symmetric and transitive. Reflexive, symmetric and transitive. Now let us recall all the points, all the types one by one. And everybody knows that the relation R is always symbolized by capital R. It is generally symbolized by capital R. So keep in mind, R is the given relation. So when a relation R will be called reflexive, let us remember. Always to be reflexive, we have to pick up a single element from the given set. So let us pick up a single element, small a, from the given set. And R is the given relation. It will be given to us. And this R will be reflexive if the same element's order pair belongs to R. Means if the same element's order pair satisfying the given relation, then it will be called reflexive. So in brief we can say, if A comma A belongs to R, then it will be reflexive. So that is the story about reflexivity. Now, what was the symmetric? To be symmetric, we need to pick up 2 elements. Let A be, we are picking up. And at the same time, we are assuming that A comma B belongs to R. Means it is satisfying the given relation. From here, by any means, if you can check its reverse order pair, B comma A also belongs to R, then it will be symmetric. That means in brief, if by any means we can check A comma B belongs to R, implying that B comma A also belongs to R, then it will be symmetric, otherwise not. Now let us come to the last point, transitive. To be transitive, first we need to pick up 3 distinct elements, A, B, C, from the given set. And at the same time, we are assuming that the order pair A comma B belongs to R as well as B comma C belongs to R. Means A comma B and B comma C both are satisfying the given relations. Already we assumed, already we know that. From here, by any means, if we can check also A comma C satisfying the relations belongs to R, then it will be transitive. That means in brief, if by somehow we can check A comma B belongs to R as well as B comma C belongs to R, implying that A comma C also belongs to R, it will be transitive. So these portions we have learned in the previous video. We got some ideas about the reflexive, symmetric and transitive. If a relation R holds all of them, if a relation R is all of them, that means if it is reflexive as well as symmetric as well as transitive, then it will be known as equivalence relation. So maximum question will be about equivalence relations in the CBSE board exam. In the CBSE board exam, maximum question will be asked about equivalence relations. That means we need to show whether it is symmetric or not, reflexive or not, or transitive or not. So maximum question will be based upon equivalence relations. So on the basis of that, we shall be doing 3 maths. I have set up 3 maths on the basis of equivalence relations. I hope it will be understood properly if we work out those examples. Okay, so let us look at the first examples. What is told here? Let R is a relation on the set L. L means it is the set of all straight lines. It is the go down of all straight lines. All kind of straight lines will be available here. Defined by R equal to A comma B such that H parallel to B for all AB belongs to L. Now check whether these are its equivalence or not. So here this line is very, very important to understand. If by somehow, if you understand, then the math will be finished by 50%. What is told here? R is the set of all ordered pairs of the form A, B where H parallel to B. This line will be parallel. Then we can say A, B satisfying the relations, means A, B belongs to R. If H parallel to B, then A, B belongs to R. If H not parallel to B, A, B does not belong to R. So first we have to understand how A and B are related. If they are parallel, then A, B belongs to R. So you have to keep in mind always. Then let us check how it will be equivalent relations. Let us check whether it will be equivalence or not. That means we have to justify whether it is symmetric or not, reflexive or not, or transitive or not. Now let us check one by one. First let us write how the relation R is mentioned. It is very important to understand first. R equal to A, B such that A is parallel to B. First we have to check reflexivity. So write the point as reflexive. We know to be reflexive we need to pick up a single element from the given set. So let us pick up, let A belongs to L. We are picking up A from the set L. We know every line is parallel to itself. Every line is parallel to itself. Every line is this line is parallel to itself. Every line is parallel to itself. So we can say here A is the line because it is coming from the L set. L is the set of all straight lines. So we can say H also parallel to itself. H also parallel to A. So H parallel to A means A, A belongs to R from the given definition. If H parallel to B, then A, B belongs to R. Here H parallel to A because H parallel to itself. So obviously A, A belongs to R. So by the definition we can say R is reflexive. My first point has been done. Now let us come to symmetric. Whether you have to check it is symmetric or not. And we know to be symmetric we need to pick up two distinct elements. So let us pick up A, B belongs to A. So you have to explain in the proper way. Otherwise marks will be cut. Let us pick up two distinct elements from the set L. And at the same time we are assuming that A, B belongs to R. This order pair satisfying the relations. We assume that A, B belongs to R. Now look at the definition. A, B belongs to R means A and B are parallel. So from here we can say A and B are parallel from the definition. Since A is parallel to B, look at here. Since A is parallel to B, so we can say also B is parallel to A. Can I say or not? Since the line A is parallel to B from here, so we can say reversely B will be parallel to A. So we can claim B is parallel to A. So B is parallel to A means from the definition also the order pair B, A belongs to R. Can I say or not? Firstly, I have assumed A, B belongs to R. Now we have shown B, A belongs to R. So from the definition of the symmetricity, R is symmetric. Firstly, we have assumed A, B belongs to R. From here we get A parallel to B. So A parallel to B means B parallel to A. B, A belongs to R. So finally we have proved B, A belongs to R from A, B belongs to R. So it is symmetric. So you have to apply your logic. You have to apply your common sense here. This question is about common sense. Now let us come to transitive. And we know to be transitive, we need to pick up 3 elements. So let us pick up A, B, C from the given set L. At the same time, we are assuming that the order pair A, B belongs to R, as well as the order pair B, C belongs to R. At the same time, we assume that it is given that the order pair A, B is satisfying the relation, as well as B, C belongs to R. Now look at the definition. What is the meaning of A, B belongs to R? A, B belongs to R means H parallel to B. Since A, B belongs to here, A, B belongs to here, so H parallel to B, here B is parallel to C. So if you draw the figure, H parallel to B, H parallel to B. Here what is told? B is parallel to C. So from here you can say also H parallel to C. H parallel to B and B and C is parallel. So you can say from here also A and C are parallel. So we can claim from here A and C are parallel. Okay. So we can claim from here AC and parallel. AC and parallel means A, C belongs to R. Firstly we have taken A, B belongs to R, as well as B, C belongs to R. Finally we have proved A, C belongs to R. So we can claim also R is transitive. So R is transitive. Can I say or not? Okay. So here for this example we have shown it is reflexive, it is symmetric, as well as transitive. Means what? It is an equivalence relation. So we can say R is an equivalence relation because it is reflexive as well as symmetric as well as transitive. Have you understood? Now I am giving you another example to be done. This question will be a homework because this question is exactly same with the previous question. What is told here? Let R is a relation on the set L, the same story, the set of all straight lines defined by R equal to A, B such that edge height to B means perpendicular to B, and AB belongs to L. Check whether it is equivalence or not. So what is the difference between this question? The previous question was about parallel. The question is about perpendicular height. So you have to approach in the similar way. So you have to check whether it is symmetric or not, reflexive or not, transitive or not. That's why I am leaving these questions as a homework because they are almost same. You have to approach in the similar way. Okay. So this question will be discussed in the next videos. So please let you try at the home. Now we are going to do the very, very important questions. The question number 3. What is here? Let R is a relation on the set A. The set is 1, 2, 3 defined by R equal to 1, 2 and 2, 1. Check whether this R is reflexive or not, symmetric or not, and transitive or not. Here a set is mentioned. On the set, a relation R is defined, where the relation R containing 2 order pairs, 1, 2 and 2, 1. Now we need to check whether this R is reflexive or not, symmetric or not. Now let us check. Here what the question is? First let us write the given set 1, 2, 3. And the relation R is defined by R equal to 1, 2, 2, 1. That means here the relation R is containing 2 order pairs, 1, 2 and 2, 1. Now we have to check whether this R is symmetric or not, reflexive or not, and transitive or not. So you have to check one by one. First let us check reflexive. First look at the set A, each containing 3 elements, 1, 2, 3. So to be reflexive, there must be 1, 1, 2, 2, 3, 3 in R. So there must be 3 order pairs 1, 1, 2, 2, 3, 3 in R to be reflexive, but nobody is there in R. So likho, to be reflexive 1, 1, 2, 2 and 3, 3 all should be in R, but nobody is there. So these 3 elements, these 3 order pairs 1, 1, 2, 2, 3, 3 all have to be there in R, but nothing is there in R. So R is not reflexive. Understood or not? Suppose मान लो there is 4 elements 1, 2, 3, 4. So to be reflexive, similarly 1, 1, 2, 2, 3, 3, 4, 4 all have to be there in R. Nobody should miss. Suppose R is containing 1, 1, 2, 2, but 3, 3 is not there. Also even it will not be reflexive. So I am trying to say, to be reflexive, all the elements, all same order elements will be there, have to be there. Means 1, 1, 2, 2, 3, 3 all have to be there simultaneously, otherwise not. Suppose it is containing 4 elements 1, 2, 3, 4. Suppose R contains here 1, 1, 2, 2, 3, 3. 4, 4 is missing. Again, also even it will not be reflexive. So to be reflexive, there 1, 1, 2, 2, 3, 3, 4, 4 all have to be there if the set is 1, 2, 3, 4. Understood? Since here 1, 1, 2, 2, 3, 3 nobody is there, no 3 of them is there, that's why it is not reflexive. So to be reflexive, all have to be there simultaneously. So it is not reflexive. Now let us check symmetricity. Now look at the set. 1, 2 belongs to R. Also its reverse order pair 2, 1 is there, implying 2, 1 is also there. So we can say it is symmetric, because if you see at R, 1, 2 belongs to R. Also its reverse order pair 2, 1 is also there. A, B is there. Also its reverse order pair B, A also is there. So we can say it is symmetric. So R is symmetric. Why? Because 1, 2 belongs to R. Also its reverse order pair 2, 1 belongs to R. That's why it is symmetric. Now let us take the transitivity. Transitive. Now look at the set. 1, 2 belongs to R and 2, 1 belongs to R. So A, B belongs to R and B, C belongs to R. So to be transitive, obviously A, C means 1, 1 should be there. But there is no 1, 1 in R. Again I am saying A, B is there. Also B, C is there. So to be transitive, obviously A, C means 1, 1 should be there. But there is no 1, 1 in R. That's why also it is not transitive. Since 1, 2 belongs to R as well as 2, 1 belongs to R. But to be transitive, 1, 1 must be there in R. Must be there. To be transitive, 1, 1 must be there in R. But 1, 1 does not belong to R. So you can say R is not transitive. Understood or not? So we have checked this example. In this example, R is not reflexive, not transitive. Only it is symmetric. So have you understood the logic? If you don't understand properly, please inform me. Please comment on my videos. I shall let you know later on in the next videos. So we shall be meeting with the new videos. So today I stop here. Please be safe, be healthy, and please stay at the home. Thank you very much.